Good morning, eighth grade. I hope they're having a good start to our day, good start to our morning. This week, the video is going to be about choice of unit. Now, this is something that you've been doing for a long time, like I've said in the video, but it's going to be a slight different spin on things. So, without further ado, let's get to the video.
All right, eighth graders, today we're going to be building on something that you actually started learning about even in kindergarten. It's called choice of unit. Now, for you, especially when you were younger, this was things like what makes the most sense for a unit of measurement for a banana? Do we want to measure a banana in centimeters, inches, feet, yards, miles, different things like that? But now we're taking it onto a larger scale, and especially we're going to take it in terms of scientific notation, at least for our second example. But let's start off with our first example. I think something that you all can relate to. A certain brand of MP3 player, we can even call it an iPod if you want, will display how long it will take to play through its entire music library. If the maximum numbers of songs the MP3 player can hold is 1,000 and the average song length is 4 minutes, would you want the time displayed in terms of seconds, days, or years worth of music? Explain. Well, I know that if it can hold 1,000 songs, and each song is roughly 4 minutes, that means that this is going to come out to be 4,000 minutes worth of music. So I'm going to put that unit on there because that's important. So if I wanted to figure out how many seconds this would be 4,000 minutes times 60 seconds. So that's going to come out to be roughly 240,000 seconds. I don't know about you, but that's not very convenient. And I know I already did this math for you when it comes to the amount of years worth of music. This comes out to be actually 5 over 657 years. Whoops, 57, not 77. So, I don't know about you. I really don't find it that impressive if I tell somebody or if I tell a family member, I've got 240,000 seconds worth of music. That doesn't really mean much. And again, if I'm trying to think about this in terms of years, this is only 657ths of a year. What does that even mean? Okay? But in this case, I can easily say that when it comes to days, this is roughly 2 and 8 tenths of a day, or 2 and 8 tenths days worth of music. Now, I think we all can agree that it's a little bit easier to understand that I have almost 3 days worth of music on this MP3 player instead of 240,000. That doesn't really make much sense. It's not really appropriate for the context, and 5 over 657 is definitely not appropriate. So in this case, our appropriate unit would be days. So now that we kind of have a feel of ideally what we're trying to do, let's take this and try to do this with scientific notation, because eventually we're going to need to change our numbers that we have to fit what our new unit is going to be. So, suppose you are researching atomic diameters and find that credible sources provided the diameters of 5 different atoms shown in the table below. All measurements are in centimeters. That's good to know. Thank you. So, I have 1 times 10 to the negative 8th power. I have 1 times 10 to the negative 12th power. 5 times 10 to the negative 8th power, and 5 times 10 to the negative 10th power, and 5 and 29 hundredths times 10 to the negative 11th power. First question, what new unit might you introduce in order to discuss the differences in diameter measurements? This is a little bit difficult because we're being thrown into scientific notation and we're not really sure what to do. Okay, but really what we're trying to think about is what exponent or what 10 to what exponent is going to be most appropriate for all of these examples that we have. So I'm really looking to see, I have negative 8, negative 12, negative 8, negative 10, negative 11. I look to see a lot of this is really centering around 10 to the negative 10th. So that's actually going to be my new unit. Okay, it's 10 to the negative 10th, whatever that is, 10 to the negative 10th centimeters. Okay, and it's because it's the average of the answers. Now, you could have said 10 to the negative 12th because all measurements could then be expressed without exponential notation, or you could say 10 to the negative 8th should be the unit because two measurements are already of that order of magnitude. But in this case, it might be much appropriate to say 10 to the negative 10th because it's the average of all powers. So, question 7. Name your unit and why you chose it. So, you can name it anything reasonable as long as as long as you clearly state what your unit is and how it'll be written. Um, let's say you chose 10 to the negative 10th, then you could state that your unit will be represented with a letter. So let's say our unit is going to be y, and y equals 10 to the negative 10th. Okay? So that's what we're going to roll with. We're going to say that y is how we label our unit. So, using the unit that you have defined, rewrite the 5 diameter measurements. So this is what I need to do. I need to take 1 times 10 to the negative 8th and change it so that way it's times 10 to the negative 10th. So what I need to do is I need to take 1 times 10 to the negative 8th, and I need to rewrite it so that way it has a unit of times 10 to the negative 10th. But here's the thing. I need to be able to write it in this new unit, but it still has to describe the same number. And here's what I mean by that. When I change the unit, it's not like overall the meaning of the number is changing. Okay, it still has to represent the same number. So what I'm going to do is I need to figure out what is the difference from 10 to the negative 8th and 10 to the negative 10th. So since I'm trying to find this difference or how many times greater this is, I need to do 10 to the negative 8th divided by 10 to the negative 10th. Because that'll tell me the difference between negative 8 and negative 10. So what I can do is I see that it's about 10 to the second power, or 100 times different. So what I can do in order to rewrite my new number is I take my original number in front of the times 10 to the negative 8th, and I multiply it by what that difference is. In this case, 10 squared. So 1 times 100 obviously is 100. So I can change 1 times 10 to the negative 8th to be 100 times 10 to the negative 10th. So let's try this for our other examples. So we have 1 times 10 to the negative 12th. And I'm trying to change that to be times 10 to the negative 10th. Oh, I'm sorry. I can also rewrite this as 100y because that's what we said that our unit was equal to. Y equals 10 to the negative 10th. So, in this new example, I need to figure out what is the difference between negative 12 and negative 10. So I need to do 10 to the negative 12th divided by 10 to the negative 10th. That will show me that the difference is negative 2, which if I relate back, so this is the same thing as 0.01. So if I relate this back to my previous example, no. So I know that the difference is approximately 0.01 because that's what 10 to the negative second power is equal to. I know that I can do 1 times 0.01, and that is going to equal 0.01. So I know that my new is from 1 times 10 to the negative 12th. That ultimately becomes 0.01 times 10 to the negative 10th, or 0.01y. Let's try this for our next example. 5 times 10 to the negative 8. I'm trying to change this again to be times 10 to the negative 10th. Well, we already did 10 to the negative 8th. The difference between 10 to the negative 8th and 10 to the negative 10th was 10 squared. So I just need to do 5 times 100, or 5 times 10 squared, which gives me 500. So I know that I can rewrite this as 5, or from 5 times 10 to the negative 8th to 500 times 10 to the negative 10th, which is the same thing as 500y. Two more examples. I have 5 times 10 to the negative 10th. Well, that's already in our unit that we want it to be, 10 to the negative 10th. So this just gets to be rewritten as 5y. And then our last example is going to be 5.29 times 10 to the negative 11th, which is this, I want to change that to be blank times 10 to the negative 10th. So I have 10 to the negative 11th divided by 10 to the negative 10th, which is the same thing as 10 to the negative 11, not 0.11. Let me erase this really quick. 10 to the negative 11th minus negative 10, which ultimately comes out to be 10 to the negative 1st, or 0.1. So I can do 5 and 29 hundredths times 1/10, which ultimately becomes 0.529. So from what was 5.29 times 10 to the negative 11th, it can now be rewritten as 0.529 times 10 to the negative 10th, which is the same thing as 0.529y. So, those are all of the examples that I have today. Again, it's important to remember what we were kind of talking about last time, even in our last YouTube video. That will help you in this one. But it's also important to know that finding a new unit can be difficult, but we're just trying to find something that represents the data that we have, whether it's in scientific notation, like in our second example, or in our first example, something that just represents or fits our situation appropriately. So those are all the examples that I have for today, and until next time, I hope that you have a great day.